Yeah, good evening, everyone. Uh, Welcome to One GIS on Solution. So today, today's webinar is more than just a session. It's a step towards understanding the future of GIS in India across the world. So our expert speaker, Mr. Lokesh Naik, will guide you through GIS foundations, spatial thinking, and real world application. It would be help you for your future to shape in GIS. And let's start. Okay, Mr. Lokesh, you may proceed.
Yeah, thank you. And hi everyone. Good evening. Welcome to One JS One Solution. And I'm Lokesh Naik, and I'm working in Forest Department as a scientific administrative associate. And I'll be guide you how will be the basic and what will be the GS really means, and how the GIS, GPS, remote sensing, and those data, how we're going to handle and how we're going to take care of that, how we're going to expert, we'll see on this session. So, most of you people, maybe BSc, MSc, PhD scholars, you might be know how GIS is important in our everyday life. So may I know some of them if you people okay with unmute yourself and tell what majorly you people work or college, or even you can drop a message. So we'll have a interaction between us. So the session will be the more good if we interact both sides. Anyone can share their college or what they are studying and how they, if they are working, or if people are working in some companies or researching. You can share with us. So let be interactive session, interact with each and everyone, so it will be more helpful to you and the speaker. So if you guys able to uh, text, yeah, you can text or you can unmute yourself and you can tell. Yeah, Nitin, you can share how is your college life, or your workplace. Suhail, Prahal, Prajwal, Sunny, Sumita, Vipal. Okay, that's fine. If you are okay with dropping the text, just drop. So meanwhile, we'll start our session. I will go for introduction. One. Yeah. Is it visible? Is it visible to you guys?
No, no, Lokesh. It's
Oh, it's not visible. Okay, fine. Let me change. Hmm. Yeah. Now is it visible, right?
yes, yes.
Yeah. So, guys, today we are starting a free webinar on theoretical session of mastering GIS concepts, spatial data, and mapping fundamental and career guidance at the end. So, basically, what is GIS? So, everyone speaks about GIS. Yeah, this GIS will be help us in navigation, mapping, and interpretation, analyzing, collection of data. So what is really the GIS means? So the GIS it is a computer based framework which is captures, store, and checking and displaying, analyzing the data where which is actually present on Earth's surface, and which is connected to a data of map, integration, locations, and all type of the descriptive information which is stored in attribute table also. And in GIS, there are the few things which is very play very important role. So mainly the geographic and information and system. What is geographic information system? Which we divides these three. So it's kind of the you can see the image which is the cake. So here geographic, all the geographic informations all stored, and information geography is spatial analysis, spatial data which is having, so we will store in the information and we will analyze in the system. This is the mainly what GIS means. So here you can see the spatial data components where real world connect coordinates, shapes, and locations on the earth surface, and information which is the tabular data, which means attribute data, which is representing underlying spreadsheet database containing attributes, numbers, and all. And in like system, all these geography information always to analyze in the QGIS, RGS, Eradas, Google Earth Engine, and many other softwares. So how we will going to analyze? So here you can see in like we have divided into the layers. So in the layer one, the real world satellite imagery are aerial photos. So the satellites, we will capture some of the satellite imageries or aerial photos, like for example human infrastructure, buildings, properties, and parcel of the boundaries. And also we will have the transportation networks like linear features like street, highway, railway roads, and also some environment assets like forest cover, water bodies, which has polygon layer. And also in layer 5 we have the digital elevation model, which is the raw shape, slope, height, and the terrain. These are the main aspects. If a geographer, I mean if a GIS analyst, if you want to become a GIS analyst, these are the basic things you have to be prepared in your mind. So in analysis purpose, if you don't you can't face any problems if you know all these things. And in GIS, what are the applications? Yeah, we will know the GIS is collecting the data or downloading some satellite images, and we having analyze LULC, NDVA, and all these things. We will analyze. We know that. What are the applications? So GIS works in different applications. We know that. For example, forestry, in infrastructure, in fire applications, and navigation, and marine transports, and also in real estates. So how we will work on these things? In forest cover, you will going to map the forest cover, deforestation, afforestation, and forest fires, and water bodies, and wildlife, animal tracking. You will going to do that. And how will be the soils and the soil structure and layers, all these things. If you comes to the, if you planning the urban city, what will be the basic necessity needed to the people, what will be the road path, what will be the structure of urban, what will be the greenness where we can adopt that. We will going to map all those things. In fire forest and fire urban or any fires, if you're going to do these things mapping, you will have some thermal bands. According to that, you will going to map some of the satellites. See, some of the satellites are having not much interval time period. See, some, for example, if you have the Sentinel satellite, it has 15 days interval time period. So most of like these kind of the forest fire or city fire, you have to depend on the aerial photographs, drone photographs. And in navigation or marine transport, you have to navigate the route and all these things. You will going to map how the marine organism, what is the ocean humidity, what is the salinity, temperature. You will going to map that. And in, if comes to the real estate, you will going to map the parcel boundaries, and other things. These are the some applications in GIS we will going to the use. And yeah, these are the some basic things about the GIS. Now we will dive into the what is GPS and GIS and remote sensing. See, GPS, GIS, and remote sensing. These are the main three pillars. What we say, it was three main pillars where GIS sustaining till now. So GPS, which has giving the location coordinates and all these things, remote sensing, which is the sensing the data, and GPS will be combined. The both GIS remote sensing, GIS will be applying, right? So we will see that. So mainly, firstly, we will discuss about the GPS. What is GPS and how the GPS will work? See, if you are at home, or you are at workplace, you are outside, or maybe you are some other restaurant or some other places, and you can think that, yeah, where I am on earth. See, you are for example, you are staying at the Bangalore, the GPS location, if you on the your GPS, then you will going to know that, yeah, here I am, this is the exact place where I am belong, where I am staying now. This will be what deals about the GPS. So there are the main some components in GPS system. There are the, see, we can see that satellite segment, also called as space segment, and user segment, and control segment. How the GPS will actually works, we will see on these three components. If you see this diagram, in the space segment, you have some 21 active satellites, and 3 space and 6 orbits. Each orbit have the 55 degrees inclination, because our earth has inclined. This is the reason we have what are the satellites are launched. It also has the 55 degree of inclination, and also orbital equal space around the equator. There is the equal space around the equator if you launching the satellite something. And if you see the control segment, you have some monitor stations. There are the mainly 5 monitor stations. We will discuss about the 5 monitor stations, and all the satellite data will be comes to the monitor station, and these monitor station will be analyzed and corrected if any errors are occurs in the satellite, or images. So it will be rectified, and it will be corrected, and it will sent back to the satellite, and it will be corrected when you will going to download, right? And in user segment, you can see the how in user segment, we are the users, right? We are the users. So we will go into the download, we will analyze, we will plan, we will predict. All these things will be happen for the user segment. So here we have mentioned some see navigation L1, L2. The L1, L2 are the frequency band, which is the satellites have be send the signals, which has L1 band of the 10.43 MP. For this kind of the things, we will discuss on some courses in detail. And these are the ranging codes and the system time clock corrections. If the satellites have some destruction in time, so it will be rearranged by the control segment. And propagation delay, if you the satellites is passing to a speed or something, it will be corrected. And vehicle, and the vehicle health means the satellite, mainly the satellite health, how the satellite is working, if it is working properly or not, it is the active or the passive. So we will going to discuss all these things. If comes to the first, in space segment, see, in space segment, there are the presently 24 orbiting satellites. See, it has differ from to nation. If for example, if you go to the USA, they have their own satellites. If it comes to the India, we have the same some we satellites like Navicstar and all these things. So this GPS is the kind of the satellite which is belongs to the USA. And we have the 21 operating with a 3 fully functional space. And these satellites orbits are approximately every 12 hours. It will be passed through the exact the same twice a day. I mean, if a satellite which is come to the one point, and it will be pass 2 times in a day at the same location. And also the if you want to see your location right now, so minimum 4 satellites should be there to accurate location where you are present now. So this is the main thing, basic things we need to keep in our mind. And each satellite have the 55-degree inclinations. I have mentioned that one. And the satellite networks is designed minimum 4 satellite, as I told. If you want to see your location, minimum 4 satellites has to be in 4 satellite has to be present in your range. For example, every Android phone has their satellite ranging. For example, if some of the applications are available in the Play Store, so you can download and see some of the satellites where just your head over, like how many satellites are present on just to your range. So we can, all these things we can see. This is the space segment. So, and if it comes to the user segment, like us, we are the we are the one users using the satellites, analyzing and all these things. So in user segments, the user will be receives the GPS signal, and he will designs or rather simplify, and typically receivers is composed for an antenna. So if you want to get a signal in the past days, you will not have some smartphones and all these things, but we have now. Yeah, we are pleasure that for that. So at the first we don't have some of the instruments, so we will have to depend upon the antenna and radio signal to get the signal, and signal microprocessor, display and control device. These are the basic instruments where we need to carry out, so we'll get accurate GPS data. In control segment, there are the 5 monitor, as I mentioned above. There are the 5 monitor stations scattered across the earth. So you can see here Colorado Springs, which is master control station, and having the Hawaii. Yeah, see, this is the one, Colorado and Hawaii, and Ascensia, Iceland, and Diego, and Kozlenia. These are the 4 stations. 4 stations are the substations. This is the master control station, Colorado Springs. All these and Diego and Ascensia and Hawaii. These are the stations which has correct the satellite data, and then it will be sent to these Colorado Springs. So these Colorado Springs master station will be correct everything, and it will be going to rectify all the things, and it will be sent back to the uplink to the stations. This is the control segment. And now we'll come to the remote sensing. As we completed the GPS part, we'll come to the remote sensing. See, remote sensing, the most of the geography students knows this remote sensing, how it will work, because it is completely correlated to the solar budget, heat budget. So here there is a satellite, and here it is Earth. So what happens mainly? Sun sends the rays to the Earth surface, and Earth surface will be some of the clouds and other dust particles, and other will be reflected back. The rays will be reflected back. At the same time, what are the minimum ray of the sun will be reflected, I mean observed by the Earth. They have some DN values which will be recorded back to the satellite. So these satellite will be sent to the control station. All the data sent to be control station. The control station will be what do, it will be correct, and it will be do all the corrections regarding any errors of the satellites or these things, and it will send to the uplink to the again satellite, and it will directly provide it to the user. So this is how the remote sensing works. So there is any physical barrier, without any physical barrier, acquiring the data is known as remote sensing. So we'll see that. See, here we have mentioned the core role of remote sensing is what does it look like from the distance. In the distance, if satellite is placed far from us, it has about 7,000 uh, 36,000 above from the earth surface, and without any physical contact between the satellite and the user, we are collecting the data. This is how the remote sensing works. So how it works, here see, we can see process of acquiring the information of the earth surface with the distance, from the distance, without making any physical contact, right? and it is sensor is mounted like satellite, Landsat, and Sentinel. Just satellites are mounted at space, and others aeroplanes, drones, and these are the adapted with the sensors. So with the infrared and radar waves, we are collecting the information from the ground. What is the primary output? Primary output will be imagery, aerial photographs, pixel grids, the mainly the raster file, and 3D point clouds. These 3D points cloud will be mainly gathered from lidar, right? Lidar. And what is the, if we have some real world examples are like this. Space satellite takes the multispectral MSS, multispectral spectral, and orbit capturing the real infrared light and themselves, which part is the canopy health, which is the part of the burner or dry. See, we are using the multispectral images. We will download the satellite image, and we will analyze that one, like how it was looks actually, how it looks like that. So for these, you need to know, you need to understand the EMR, electromagnetic spectrum. Here, electromagnetic spectrum, there is a narrow path, a small narrow path, which is having 0.4 mm to 0.7. This is the visible range, also known as VIBGYOR. So in these, the narrow path, we the eyes only can see with this narrow path between, which has ultraviolet rays and near infrareds between a called visible light. So here, by these only we can see the red, green, blue layers, has we classify in our supervisor unsupervised classification, FCC, NCC, natural color and false color. So this is how the important role plays. And the GIS, see, we can came to GPS segment, right? In GPS segment, we done with the GPS and remote sensing. By now, we will combine these both, remote sensing and GPS. Will combine, the output will be, and the final output gives the GIS. How the GIS will give output using the GPS and remote sensing? We'll see that now. Yeah, GIS means how it will work. It will the bring different data sets together. Different data sets together. What are the data sets? Maybe the lat long, and the image, raster image, vector image, which is downloaded from the satellite. Mainly with the, I mean, the raster image downloaded from satellite, and the lat long will be the vector data. And the coordinates, imagery, remote sensing layers, we will place a top on each other, and we will create the attribute table, and we will merge, and we create the final output maps. And these are the final output maps, like a thematic map, analytical reports, spatial statistics, and productive models, right? And in real world examples are like, see, satellite images, remote sensing, boundary lines from GPS. Remote sensing is the one of the part, and GPS is the one of the part. And import, we both the data, GPS and remote sensing, we imported into the QGIS and RGIS. We will overlay like local villages, calculate the exactly how much the villages boundary, and we will locate, and the and we will create the 5 kilometer buffer of the fire boundary, and we will, like this, we will going to analyze all these things, right? And this is how GIS GPS will be work in this second segment. So even in GIS, we have some main four major components, which is the hardware, software, data, and people. In hardware, yeah, we will need some hardware components like GPS, lat long locations in satellite images, the raster files, and all these things. In software, we have RGS, QGIS, ERDAS, Snap, and all these things. We need to know how the software will be going to analyze these data sets. And what are the data sets? Data sets are the some coordinates, maps, raster, and all these things. People who will going to do all these things, people's users, we like analysts, specialists, and other developers. Yeah, I have mentioned some difference between the GPS and remote sensing and GIS. GNSS is nothing but Global Navigation Satellite System. Global Navigation Satellite System. In GPS, primary action in GPS, what we'll do? Exact position on the Earth, like means lat long, and remote sensing, we will collect the imagery data from the distance. And GIS, both the location and the collected imagery will be analyzed in GIS. If it comes to the hardware used, what will the hardware part? It will be satellite. The satellite will be provide the latent locations, right? And receivers, who are the receivers? We are the receivers, and from antenna, smartphone, we will receive that. And if it comes to the remote sensing, satellite, airplanes, drones, optical cameras, lidars, these are the some uh, uh, components where we will acquire the data from remote sensing. Both together we will apply in GIS, in computer data set servers and cloud infrastructure and all these things. What are the data format? In GPS we have some lat long point data, and remote sensing we have raster pixel images, continuous data grids, and both we will combine and we will apply in the GIS point line polygon. We will combine, we will join the attribute tables, we'll get accurate the data using the GPS remote sensing. What will be the analogy? Yeah, analogy, it is like compass, tape measure, how it exactly will there. And what will be the remote sensing like camera, how it what is the resolution, and we will all these things will look into the remote sensing. And in GIS we will combine the both, right? And we will overlay the measurement, and we will overlay the raster image, and we will solve the problem. This is how work GPS, remote sensing, and GIS together. So we need to know like what will be the most important part of each remote sensing, GIS and GPS. So if we know all these basics, so we can apply it anywhere, and how we can things, right? Yeah, and next we'll understand how the vector and raster data really works, and where we from will get. So here in real world, we can see like these images. See how it was like that in real future. We'll see like this. If it comes to the raster, we see in the pixel format, right? In the pixel format, it has own DN values, right? It has own DN values. And in vector data we have point location, right? Point location, line feature which is connected to through points, and the polygon feature. See polygon feature, how the data is continuous in grid format. See, this is how the vector and raster data will be worked. Yeah, we'll discuss in detail. See, in vector data, what is the data structure in vector? It is the highly complex coordinate points, highly complex coordinate points like lat long, or some your location, maybe for example your location and your friend location, or some your college or your workplace locations. These are the some of the other points of the locations. And if it comes to the raster model, we have simple metric grids and rows and columns which has the continuous data, right? And if it comes to the, if we want to represent the data, how we're going to represent the data? The vector will be discrete object with the different shape and border, right? If it comes to the raster data, we have continuous phenomena varying across the surfaces. So basic geometric, what will be there for the vector? It will be point, line, and polygon. If it comes to the raster, there are the pixel data which is continuous and grid format, right? And if it comes to the, what are the volume of the data, it will be file size, generally smaller in vector data and highly in raster data, which is differ from the satellite to satellite or the drone images. See, if you go into the drone images, it will be highly the size of file will be large. If it comes to the like satellite images, for example, you have analyzer for Landsat data or Sentinel data, you will get in the 1 or 1.52 GB of one image, one tile, right? So this is how the file of will be differ from raster to the vector. If coordinate precision, extremely high precision in the vector. And if it comes to the raster, it will be differ from the satellite to satellite. And what are the main component we are using? Like if you are using the sentinel, it has a 10-meter resolution. If you are using the landsat, it has a 30-meter resolution. If you are using the some GOI, some other satellites, it has the list 4. They have 0.5 meter resolution, 0.2 meter resolution. If you're using the drone image, it is a highly resolution. So for how the resolution varies, it will be that much of accurate precision will be get right. In main operation, what are the main operations in the vector? If you're going to see in vector, there are the buffering, network topology, overlay, analysis. See, for example, if you are doing in buffering, if you are doing the analysis of buffering, there is the one road, so the government is trying to expand expand the road, right? See, for example, this is the road, and the government has expanding the road up to 5 kilometers, right? So the road will be here, and from this side the road will be expanded for 5 kilometers. So the road will be here. So the total length of the road is 10 kilometers width, sorry. The total length of the road is 10 kilometers. This is how bufferlay will be work. And the network topology, see, you are staying here, and here your friend, in here it is your workplace. How the distance, how the network will be connected to you and your distance of workplace and your friend's house. This is how the network topology will be work. And the overlay analysis, you have a one area. So in this area, you have a some point feature and line feature and polygon feature. So how we're going to do these things? You have a raster image and also vector image. So you can overlay these things. So you have a multiple images. So you will overlay to get a one compact image. This is how it will be works. Right. Okay. Next, file format. What are the file formats you will get into in vector and raster? You will get just a second. Let me choose pen. Yeah. In file format, you have a SHP, Johnson, KML file, and geodatabase, and also KMZ. These are the some file formats you have present in vector. In raster, you have map, algebra, continuous surface filtering, NDVA, and other features. In analogy, you have vector smooth blueprint drawings and digital, sorry. Yeah, in main operations, you will do here buffering topology overlay, and here will be map, algebra, continuous and filtering, NDVA analysis, and LULC analysis, NDWA, and other analysis. In file format, you have the GeoTIFF and IMG and PG and DEM, all you know. And in analogy, you will have digital photography, grid map, colored blocks. These are the some vector and raster difference between the vector and rasters. So we'll move to the next part, which is very important to future GIS analyst and for MSc student who is doing the current project now, and for PhD scholars, they are come from the geography background, they know the basics, but the applying, how they have to apply, how they have to adopt it, this will be very difficult, and which is a very frustrating movement for the beginners especially. So you have two locations of for example, you have a location, and your friend is shared his location to you, and he calls you to come. So if you put into the map, it will be showing some floating on some on ocean. So this is because how this is this error due to the map projection. The projection is not, or some, for example, somehow your university or your workplace haven't given some point data or line data, which you add into your RGS or QGS panel, it will be showing on some oceans. This is because of projection. The projection is not done, or the projection and the boundary, it will be the different. Some of them CSR, some of them PCRs. So this will be the main problem. So how to fix? to understanding this fixing of the coordinate reference system and map projection, which is very important. And georeferencing is we'll discuss about that all these things. See, we can see here how the terrestrial earth and how will be the geoid and how will be the ellipse and how will be the sphere. So to know the projection system, these are the basic things you need to know first. So what will be the geoid? Will understand the basic background of this. So, Earth is not perfect or not smooth. It is the irregular and bumpy, slightly squared 3D shape. It is called ellipsoid. So here you can everyone like where some of the part some of the terrestrial surface which has oceans which is the deep, and they have that surface structure will be different. If it comes to the mountain Himalayas or Andes, Rocky, they have a different landscape. Or some of the Atlantic, they have a mid-Atlantic ridges, trenches. They have a different landscape, right? These are the things. So to fix a perfect projection, it's not possible. So some of the countries have designed their own projection, like they have a own. For example, we have a WGS 84 for our Earth, which is local datum 1830 for India, average 1830 for India. Like that, some of the countries have their own projection system. Here we can see the torrential surface, how it actually looks, right? How the geoid actually looks, and how the ellipse actually looks, how the sphere actually looks. We mostly know that the earth is not at exactly sphere shape, and even we know that earth is kind of not it was a bulgy thing and bulge at poles and expanded at the equator because of the centrifugal force. We know that at the rotating the Coriolis will be deflected, and the earth will be expanded at the equator and bulge at the poles. Yeah, we can see that actual spiral slightly larger in the radius at the equator than the poles, because see, we can see here how the equator is how the equator is enlarged, how the poles will be bulged because of the centrifugal force. While the rotating the earth, it has some force, Coriolis force, which is the zero at the equator, right? This will be for example, if you take a pen and tie some kind of rock or some heavy metal, just rotate it, how it will be expand. But your pen will be at the stationary position, but your the part which is tagged to your pen, it will be bulged, it will be rotated, right? The force which is generated at the equator will be expanded. This is how it will be works. See, we can see how at the poles we have 12.714 kilometers. At the equator we have 12.756 kilometers, right? Slightly it has up to 34 kilometer differences, I think. Yeah, it is not exact value, maybe. And this one. See how the spheroid is the RC actual earth surface is this, actual earth surface is this, and the ellipsoid surface is this, and you have a ocean surface. See, ocean is completely submerged into the earth. This is because of how the different landscape at the ocean and mountains and the surface of the earth. See, this is how the centrifugal force is during the rotation. This is how it will apply. It will bulge at the equator because of the centrifugal force. Yeah, this is the another images for your understanding. And how actually works the CSR coordinate reference system, how it will be works. It has the rule book tells the GIS software that coordinate numbers is the real spot at the globe. They are the two major CSR. So there are the GCS and PCS. GCS is projected coordinate system, and PCS is projected coordinate system. Geographic coordinate system, which has the 3D spatial model located place using the angle measure from the Earth center. From the Earth center, it will be measured, and it has degree set latitudes and longitudes, right? It is the best used to global tracking, regional navigation, and raw GPS of the data collection, just like lat-long. So here is the catch. So what is the catch? You have to remember these things where I mentioned the catch. So because the degrees instant of the flat units, you cannot be GCS calculate accurate surface. You cannot calculate accurate surface. So or distance in meters. In comes to the projected coordinate system, you will the map project. You will project the map, right? Project and the 3D angular coordinates and GCS into the flat into 2D surface. What is projection? First, before you understanding the GCS and PCS, you need to know the what is projection. Projection is nothing but just converting into the 3D into 2D, right? So, and there are the units. What is the projected coordinate system unit? Meters. So what is the best user? Local analysis, engineering, measurement of the forest boundaries, and other calculation. Okay, and yeah, yeah, we comes to the thematic map and map reading and visualization. Uh, So this is our second last topic. So once you process your vector or raster format of data, the align the coordinate reference system will be final step while sharing your findings. This is the cartography is mainly tells the art and science and technology of map making is known as cartography. So you need to be very good at using these maps. For example, if you are doing some of the maps, you need to know the basic elements of the cartography. For example, the layers, how we're going to align the process, how we're going to do all these things. This is what we do in cartography, which is applying the art, not only art kind of art means you can't say like history, economics, politicals, and other things. The art means the proficient, how we're going to apply, and how we're going to the think, and how we're going to the apply on science, and how we're going to use the technology to make the map. This is how it will works. So for maps versus for your reference, what is the map and thematic maps? So before choosing your color layout options, you must determine the primary purpose of map of output sheet. So reference map is just like the Google Maps, topographic hiking sheets, and atlas of political maps. What we have the atlas book. These are the some reference map. What is the thematic map? It is a mainly focus on the single specific topic, right? See, for reference system, Google Maps, topographic hiking sheets, and atlas. For the thematic map, you have single specific topic. You have to focus only on single specific topic or data distribution attribute across the landscape, right? For underlying geographic background, intentionally muted so target the statistics pops out immediately. For example, the map displaying the forest distress, crime rates by city ward or soil pH. These are the specific topic. These are the only specific topic you can use in thematic maps. See, in thematic maps, you have some of different type of the maps. Where first we'll discuss about the choropleth map. See, choropleth map is just common thematic map, which is administrative polygons like district, states, forest beat are filled with the progressive color gradient proportional to the statistical data value. See, we can see I have a population data which has shown in this map. See, it is showing 2021 data. So here we can see at the red color above 1000, which has Lakshadweep, Puducherry, Daman Diu, and Dadar Nagra, and here Delhi and Chhattisgarh, and all these are the populated states, populated in terms of percentage. Okay, these are the in terms of percentage or count. This is how we will differentiate. We will divide and we will use these choropleth maps. See here, dark color shades we will use, numerical values will be present. We will using the dark color which has highly populated, and we will using the numerical values, we are differentiated the color, which will be the dark, which will be the lighter one, which will be the medium one, right? This is how we will do this chloroplet map. For example, yeah, this is the best example, I think. Chloroplet map, how will do. We have isohelen maps, which is just like joining the equal point. We see, for example, contours. We have contours. See here, I have mentioned in the example contours, which has equal elevation height of the lines. So for example, here this is the high pressure, H is high pressure, L is low pressure, will come on that. For example, these are the lines where contour lines, which is have, for example, it have 125 meters height. Okay, here the place 125 kilometer, and this is the another place, it has the same height, 125 kilometers, I mean 125 meters, same height. So it will join the equal height of the map places. This is how the isohelene for see, there are some terms, thermocline, which is thermocline, which is known as equal temperature, salinity, which has have equal salinity, and other, there have some other equal lining joints, which has known as isoelements, which is continuous equal joining places. This is how we will going to use these isoelement maps. And we have graduated symbol maps, right? So these are the maps where we will use the some of the shades, some of the symbols to show the map into interactive interactive way. See, we can see the coloring entire the administration board. We have colored the entire the administration boundary, and geometric symbols, usually the circles, like geometric symbols where symbols use it circle. The coordinate locations, this is the one, for example, this is the point, this is the point, these are the locations which has used the circle has a buffer layer, right? We will use like this. And there are the rock counts, these are the counts, and the total specific points, which as the locations will be with the points, and constrain the artificial regional boundary lines. So for example, in real world, we will use, see, for example, active wildlife poaching incident. For example, this is the forest boundary, and here some of the anti-poaching happened. Some of the people were captured some tigers. Okay, so we will map. We will have this lat long location. We will map this, and like that we will do all the points. We will locate all the anti-poaching camps or anti-poaching incidents. This is how we will use. And at the last, what will be the professional map reading? There are the six essential element we need to know while we comes to the output of the map. If you have done everything, you done vector, raster, you analyzed the vector, you analyzed the raster, everything you did, and now you have to make it final output, and you have to represent to someone. How will going to represent? You will just take a screenshot, you will represent? No, not like that, right? You have some basic rules while doing the map layout. So we will discuss now that. Here in title, you have to be a bold clear statement answering what, where, and when. If you are choosing some of the topic, I mean you are doing a project, you have done a map, you need to specify the what the map exactly, what is the map, and where it is the location, and when it is the, what is the time interval period, right? You need to know these things. You have to present in your layout. For example, here, deforestation intensity within the Bannerghatta National Park in 2026. This will be the title. You have one map, and this is the your map, and you need to mention the clear title. clear title, which is deforestation intensity within the Bannerghatta National Park in 2026. What deforestation? Where? In Bannerghatta. And when? It is 2026. You need to clear about your title while you are presenting your map. So, what will be the legend? The legend should be which will be decoded, and which will be the color, line weights, and symbol, point symbol. Never leave a raw database column names like that. See, you can't leave like this. If you done analysis, for example, what happens if you've done a NDVA map? Okay, in NDVA map you analyze it, you have put at the formula plus 5 band 4 band 5 divided by band 4 band plus 5, like that you had divided it, you got the analysis, and you can't put the same analysis the what you got in table of content, you can't put the same the name, you have to rechange, you have to clean the data, and you have to assign the canopy cover in percentage. I mean, if you are analyzing the NDV data, you will have to provide NDVI, NDVI range from 0 to 2 or 0 to 1, like that. This will be the proper way you have to provide your legend. So the legend will be, and the legend is added here now. So we have done with the map, and we have done with the layer title, and we have done with the legend. Next one, scale bar. This is very, very, very important. If you wouldn't put the scale bar, no one knows the what is the measure of the map, right? So you have to put the real world distance context. So judge the distance accurately. 1 centimeter of the paper is equals to 5 centimeter, equals to 5 kilometer on the ground. See, for example, you have the map. This is the map. Okay, in the ground, it has in this map you mention 1 centimeter is equals to 5 kilometer on ground. 5 kilometer on the ground, the 5 kilometer ground on ground which is represented in 1 centimeter. So this is how the scale bar, and you have done with scale bar now here. Okay, this is scale. Okay, this is legend, legend, and this is you have done with title. Okay, and this is your map. And what else? Next is north arrow. Without north arrow, which direction of this map is representing, never knows anyone. See, some of the maps will be represented at the south. Some of the places. See, for example, this Bannerghatta National Park. Bannerghatta National Park, which is located in the South India of Central South India, right? So we need to specify the direction of the map, which direction, where it is exactly located. So to locate that, the north arrow is very essential. So we will put the north arrow here. Okay, here north arrow we have given. So this map looks good now, right? Yeah, I have prepared the maps, I'll show that now. And what is the source of attribute? Source of attribute you have to mention, right? Where you got this map, where you taken this map, where you how did you prepare the map, you need to mention that one. For example, Karnataka forest boundary in 2026, it builds the institutional trust. So like this, or some for example, if you are mentioning some source of data, some USGS, Eurospace Agency, or Copernicus. So these are the some source of attribution. And map border and grids. After all that, you need to mention the grids. Grid also a essential part of these six. So this is how you will going to make a professional map. See, I have mentioned the one map here. You have a map. This is what indicates the title is a spatio-temporal analysis of land use, land cover of Raichuru Taluk, which has presented in the Karnataka, somehow North Karnataka part, which has analyzed 23 to 25, right? what we are doing, spatial temporal of land use. Just a second. Okay. What we are doing, spatial temporal analysis of what, land use, where, Raichur Taluk, when, in 2023 to 25. Here it is the map which is analyzed the LULC for 2023 and 2024 and 2025. And here it is the legend, here it is the north arrow, here it is the scale, here it is the, what here it is, a source of attribution. Here it is the source of attribution, where you see here we have discussed source of attribution. Here is the source of attribution. Projection coordinate system data source is the Sentinel-2, ESA, world cover, and 2023, 24, 25. This is how the your final map output should be looked. Yeah, this is today's session. What are the we have discussed from the first we have went from what is the basic GIS, and we have discussed the what are the layers and how it will be, what are the GIS application, we have discussed that one, and we move on to the GPS, GIS, remote sensing, and also components of GPS, space segment, user segment, and control segment. And we know that how GPS and how remote sensing works, and how the GIS and what are the components, and we have seen the difference between the GIS and GPS, and we have discussed the vector and the raster model comparisons, and also we went to the some coordinate reference system and how will be the map projection system. Yeah, I have mentioned, I have forgot to mention that map projection we know that WGS 84 for the India Everest 1930. For these georeferencing, I have forgot to mention the georeferencing part. Georeferencing, for example, you have topo sheet. So for the topo sheet, you in RGS or QGS, you will going to give the coordinates of these four corner, I mean these 4 points, and you will be referred to some WGS 84 or some other thing. If you want to, these are the different types. So you have to georeference 4 into 4. Here are the 4 corners. You have to georeference 8 into 8. There will be the 8 corners, for example, here, 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 and here. So you will going to take this 8 into 8, and you will go into the 16 into the 16 georeference. This will also, the reference system will be included. For example, the topo sheet will be have 16 types, like this: A, B, C, D, E, F, like that. And another is you have to georeference image to image. See, you have a base map, okay, base map, and you have a image which is downloaded from Google or Google Earth Pro, right? You will go into georeference this image to your base map to exactly overlay on the base map. So it will be very for analysis purpose, it will be very good when you georeference image to image or topo sheet to topo sheet, image to topo sheet to image. This will be done in georeferencing. It will be very very basic, and it will be very easy. In upcoming classes, Mr. Basavaraj will going to take this practical session what we have discussed till now: the vector, raster, GPS, and GIS, remote sensing, lidar, satellite image processing, and all these will going to happen the practical session in upcoming sessions. Will going to take Basavaraj, and these are the all the outputs will going to take. See, map scale, legend, sorry, north arrow, the title, and the legend, and the map. All these from complete basics to advanced will have a practical session also. We will guide you in using the open source QGIS. We will do in front of you, and we will just provide some of the files. Even you can do along with us. We will guide step by step. This will going to happen. And we have discussed the how CSR and what will be the professional map, how it will looks, and what are the six basic elements. We will have looked at how will be the output of the map will be going to see done. And now we have some career guidance for the students and the beginner who is opt for GIS remote sensing. See, in GIS, we have, which is I think it's one of the smartest move for the student or the beginners, because we live in an era of 80% of the data where analyzed the spatial location component. See, everyone depends on the lat long, everyone depends upon the GPS, everyone depends upon, see how the Uber, Zomato will work. It all about the GPS. How the if for example for you have booked some Rapido or Zomato food, and you can able to see the map where the driver is coming, where will be the partner, your Rapido partner will be there. You will going to see how using the GPS will analyze it in the GIS and will created the map. This is how will going to work, right? And everything will be tracking from earth surface to the space, from ocean to the Himalayas. Everything will be tracking, everything will be monitoring. So upcoming days, GPS, GIS and remote sensing will be the most where coming to upcoming companies, upcoming people will going to adopt with these things. So if you are working with the GIS analyst or the technician, right? If you are opt for GIS analyst, what they actually do? They actually do the cleaning the data. They will clean the data, georeference the scanned records, vector editing, querying, attribute database, running the spatial overlay, processing the polishing of map. No one, see, if you go and ask some BIM or some management student, no one will do all these things. They will need the GS student. See, if some administrative bachelors, they have some data, uh, providing the data in the table format or the text format, which is better than the providing in maps. If you show in visualization, in map visualization, it will be more productive, it will be very interesting to the viewer, right? This is how the GIS analyst work will do. And who love the geography, visual design, problem solving, working the directly with the software interface will be done by GIS analyst. If you comes to the GIS developer, see, these are the people who will the write the script, automated the task, create the customs, plugins, develop the plugins, interactive web mapping applications, all these done in JS developer. These are the people will play the major role. After that, these are the people will play the major role, right? These two people use what? Remote sensing data, Earth observation satellite specialist. These are the peoples where do the space satellites work. They work with the space satellites, aeroplanes, drone data streams, analyze the multispectral imagery, radar, lidar, cloud points. These are the data we're going to analyze these peoples. This is how it will be the very interesting. You will go into the getting into the you know, agencies like space, aeroplane, drone streams, and you will going to the analyze the data. It will be very interesting once you a part of this. And if you want to if you want to master in some industries, okay, you have to be a proficient, you have to be a kind of master person, just like Kung Fu Panda, right? You have to be very good at some of softwares, just like QGIS, RGS, or Google Earth Engine, or other part of also. See, QGIS, it is the open source, which is very good for students and globally for the startups, top research labs, environment organizations. It will be very helpful if you master in QGS. These organization, environment organizations, startups, and top financial barriers masters and other consultancies will be searching for you if you master in QGS, right? And if you comes to the RGS Pro or RGS, you will going to have a chance in ISRI, MNCs like MNC companies, and they will corporate enterprises and government administrative departments. All are waiting for you if you are mastering RGS Pro. If it comes to the Google Earth Engine, you will going to learn the remote sensing and GW Java, right? In GW you will use the Java and process and imagery, cloud, simple Java, Python codes, and all these will be adopted with Google Earth Engine. If you are mastering Google Earth Engine, you will definitely love the coding and all these things. So here it is. If you are master in Python or SQL or JavaScript, keep in mind you will going to adopt anywhere. I mean, you will going to take an you will going to hire at any company, or multiple companies are waiting for you, right? Python and GIS is just kind of adding more cheese into burger. Okay, if you eat the burger, it will be, yeah, some people will don't like cheese or cheese things. I know that some of the people, but it just like adding the plus point. If you learn the Python, a plus point. If you see a normal GS person and the who knows the Python, it will be completely different. Most probably give more preference to the Python person who knows the Python as well as JS, right? He will going to apply his Python skill in QGS, RGS, right? And it will create libraries like GeoPanda, Shapley, PyQGS, and all these things. And he will prepare the hundred of maps in single click, while the normal GIS person will be, he will do the 100 maps 100 times. But who knows the Python, he will create 100 maps in a single click. This is the benefit if you learn the Python. These all classes will going to happen in our 1GS 1 solution in upcoming days. So stay on. And also SQL, structured query language, backend relationship database, we're going to work on this PostGIS and PostgreSQL. These are the one of the productive applications in using JS and JavaScript. These are the open layers and System JS 3D global visualization. If you go and check into our web dashboard, these are the things we have already worked. We will share into the group, and we will going to soon we will going to take all classes on these things, so you will going to make good uh, good at JS. So what you have to target mainly, yeah, that in career you will going to take the GS. It will be very good for the students and beginners, and it will be more, this is the era we live, and all that data, spatial data, in somehow in hands or other hands and your hands. So in you will going to do analyst, developer, remote sensing. We have separate goals, and we will master in QGS, RGS, Google Earth Engine, and we have a coding system, Python, SQL, JavaScript. Yeah, we have learned all these things. So where we have to target? This is the main question. Here it is. You have to target at government and administrations, just like Forest Department, Urban Development Authorities, Survey of India, and municipal smart cities and control hubs. See, if you are good at everything, Forest Department are waiting for you because they need a coders, right? The coding development, the who makes the map good, the Survey of India, I mean, like who do the work smartly, and the smart city who will plan and design the accurately, right? And other environment and NGOs who will interested at climate changes, and wildlife conservations and agriculture monitoring boards. These are the things, these are the administrations, these are the NGOs you have to target. If it comes to the corporate and tech industries, you need to mainly focus on MNC companies, just like 5G cell towers and logistic deliveries corporates like Uber, FedEx, regional delivery networks, or Flipkart, and all these things. Most of the GS people are working on this. Without GS, no one can map this Uber, FedEx, and regional delivery networks. Most, see, I can't say 100% GS are using these things. Yeah, somehow 50-50 or 60-30, 60-40 are working at all these things. So this is how we are going to uh, do all the things. And okay, just a second. uh, and huh, by these will done our theory session. Okay, and now I want to know, do you people have any questions on regarding today's session, or any doubts or anything? Do you people have? Just share, I'll clarify your doubt and all these things. Do you people have any doubts?